Welcome to solverfy.
In this problem of motion in a straight line, we have given that if the maximum acceleration that is tolerable for passenger in a subway is, so this is the maximum acceleration that is equals to 1.34 meters per second square. So, this is the maximum tolerable acceleration, and subway stations are located 806 meters apart. So, let us suppose this is the, we can say this is station 1 to station 2, say we are naming it as station A and then station B, and the distance between station 1 to station 2 is equals to 806 meters. What is the maximum speed a subway train can attain between the station? So, let us suppose at station 1 this would be at 0, we can say the initial velocity would be 0 and position is also 0, and from here it attains the maximum acceleration, this is equals to 1.34 meter per second square. Then until the midway point, and then say this is the midway point, point C, and then we have to decelerate it with the same maximum acceleration. So, this is minus 1.34 meters per second square, and here we have plus 1.34 meters per second square. That means, we have to find the maximum velocity at point C, or we can say the velocity at point C. So, this would be the maximum velocity. So, at midpoint AC would be equals to 806 divided with 2, which is equals to 403 meters. Now, we have the formula, that is V1 this square is equals to V0 square plus twice the acceleration, which is equals to 1.34 meters per second square, and multiplied with, say this is the distance, which is equals to 403 meters. Now, this is equals to 0 and V1 is under root of this term, which is 2 multiplied with 1.34 multiplied with 403. Now, when we solve this, under root V1 is equals to 32.9 meters per second. So, this is the answer for part A. So, we can say the answer for part A is, this is the maximum velocity, which is equals to 32.9 meters per second. Now, for part B. Part B says, what is the travel time between these stations? So, we have to find the travel time. So, this is x1 is equals to V0 t plus half multiplied with acceleration, say A1 and T1 square. So, from here we say that V0 is equals to 0. So, this is, say this is T1 and this term would be equals to 0, and now we have to find T1. So, T1 is equals to under root of, now we are finding the time taken from A to C. So, this value would be twice of x1, which is equals to 403 divided with acceleration, which is 1.34, which is equals to 24.53 seconds. From here we say that the time taken from A to C is equal to 24.53, and now from C to B we have the identical acceleration and identical distance. So, time taken would be twice of T1. So, twice of T1 is equals to, this is 49.1 seconds. So, for part B we have the time which is equals to 49.1 seconds. So, this is the answer for part B. Now, in part C, we have given that if a subway train stops for 20 seconds at each station, what is the maximum average speed of the train from one startup to the next? That means, at point A this is 20-second halt, and at point B we have again 20-second halt. So, let us suppose our train comes from any of the previous stations, say this was at station X, then when it comes to A we have to count down the time. So, this would be resting for 20 seconds and then it would be continue for motion until it reaches for B. So, we have the dead time of only 20 seconds. So, dead time is equals to 20 seconds. Now, we have to edit here. So, we can say capital T is equals to, this is 49.1 plus 20 second, which is equals to 69.1 seconds. Now we have to find the average velocity. So average velocity, total distance is 806 meters and time taken is 69.1 seconds. Now when we solve it, this is equals to 11.7 meters per second. So this is equals to 11.7 meters per second. So for part C, we have the average velocity, or we can say the average speed is equals to 11.7 meters per second. So this is the answer for average speed. Now in part D says we have to graph x versus v and a versus t for the time interval from one startup to the next. So here is the required graph I am showing you. So here is the required graph. So first is x versus t. So we can say this is x versus t, and then v versus t. So this is v versus t, and then we have acceleration versus time t. So this is the required graph for part D. So this is the solution for part D.